We're going to now look at this problem 12-88. Problem 12-88. A man is shooting a basketball and he's shooting at an angle of 30 degrees and it's going to go in the basket. He's shooting it from 2 meters from the ground. Determine the initial velocity and the velocity when the ball passes through the basket. So the ball's coming from like right here, and the person's 3 meters, shooting from a height of 3 meters, and shooting at a velocity VA and an angle 30 degrees, and it's going into the hoop back here. Which is approximately 3 meters. So the ball is going to shoot here. And if he's a good shot, it's going to go into the basket. And we're told that this distance is 10 meters. And so this time, what should the velocity be? So in other words, they have to shoot it so that it goes right to this point right here. So what is VA? What is the velocity that he has to release the ball at that it goes into the basket? And so, again, sometimes if you don't know what to do, you just sort of start writing some equations down. And just like we did before, you'll probably want to put this velocity in terms of x and y again. So let's do, to find our initial velocity in the x direction. I don't know if you call it VXO or VOX. I probably do it different every time, but whatever you like to do for that's fine. So that's going to be what your initial velocity times cosine of 30 degrees, huh? And that's a 0.866 times VA. Again, we don't know what VA is yet. Then the velocity, the initial velocity in y direction is going to be VA sine 30 degrees. And sine 30 is what, 0.5? Like this. So let's just try to write down our equation just like we did before, even though we don't know what the velocity is yet. Go back to our x equation, V xo times t 1/2 at squared. Just like before, this acceleration is always 0. Then let's start plugging stuff in. And again, let's say, let's see, how should we do this here? Once again, our starting point. So our starting point here, we should maybe name our starting point like right here. He's shooting from 2 meters. So let's call our starting point 0 in the x direction and 2 in the y direction. That makes sense. So we'll have our starting point 0 and 2. So that means that once again, the x naught is going to be 0. And then plug in the value for, 0.866 t. And finally, our x, excuse me, I left off VA here, sorry. V8T. Let me clean that up a little bit. This is going to be 0.866 VA. We don't know what that initial velocity is yet, so that, like that, huh? We could write like that so far. So let's do that. So that's the x direction. So let's also do the y direction. And again, now see our starting point for y, there's going to be 2, right? Because he's shooting from a height of 2. And then our velocity is 0.5 VAT. And again, looks like we're in SI units, so it's going to be minus 9.81 is going to be our acceleration. Like that, huh? And once again, you could, we can clean up just a little bit. We could just get rid of the half. Minus 4.905 t squared. So let's call the x equation 1 and equation 2. So now almost all these problems from now on where, unless the first one, we're kind of starting at the ground level, ending there. Almost all these other ones, there's an easier way to do it. And it would be, what I'm going to show you now, what we're going to do is substitute equation 1 into equation 2. We're going to solve equation 1 for t and put that in equation 2. Then that's going to give us an equation that relates y and x. So, and that's going to work on almost all these other projectile problems. This will work for if you're, shooting from a height, if you're going to land at an angle, if you're going to land on a hillside, this will always work. So let's do this. So we're going to solve for, what we'll do, we'll solve for t here and put it into here. We're going to solve for t in equation 1 and put it into equation 2. Let me write that down. Solve for t in equation 1 and substitute in the equation 2. So let's go back to equation 1, solve for t, and that's just going to simply be t is going to be equal to x over 0.866 VA. So we're going to just do that. Then we're going to put that into equation 2. In other words, put that for t in equation 2. 2 plus, so just write equation 2. Then whenever you have t, put this in, x. So that's going to replace t. And then for t squared, do the same thing. Let me get rid of my pointer there. And that's going to be x 0.866 VA squared, like this. So again, all I did was put that into equation 2. And now if you multiply things out, if you do this division here, this 0.5 divided by 0.866, and if you square this thing and divide it over, we can get rid of some of these numbers here, can't we? We can make this look a little bit better. So it'll be 2 plus, and then when you do this division here, you get 0.577, excuse me, wait a minute, sorry, yeah, 0.577, and the VAs cancel. So that's just going to be X. And then over on the right, when you square this and divide this up, this gives you 6.54 X squared over VA squared, like this. So now this is going to give you the position of the ball anywhere along the path if we know the initial velocity here. So let's see, what could we do? What could we do now to find the initial velocity? What could we substitute in there? Let's see, X. We would have to find. Let's see. So where is the ball? Where is it going to end? What will be the position where it's going to end up? Where would that be? What could you know, what would be the coordinates? Good. Yes, y equals 3, and then x equals 10. Good. Yeah, y equals 3, x equals 10. We could, because we know it's going to end up right at this point here, huh? So just like you said, it's going to be y equals 3 and x equals 10. Right there. Does that make sense, everyone? It's going to end up like at the basket, 10 feet in the x direction, or excuse me, 10 meters in the x direction, 3 in the y. So if we know both of those, then we can plug those in and solve for VA, huh? And put the 10 in here. Then it's going to turn this messy equation just into numbers, which is a lot easier to deal with. VA squared. And now if you rearrange everything, and I won't show all the arithmetic here, but you'll end up with VA squared equal to 137.1. And then, so VA, and then we take the square root, it's going to be plus or minus 11.71, but of course the minus won't be appropriate in our case. Because you remember what the VA is, that's at the starting velocity, huh? Starting velocity. So that means when he, back here when he shot, it had to leave at this angle of 30 degrees and at that velocity. And like I said, when you take the square root, like I said, you would get a plus or a minus here. But like I said, the minus isn't that much. I mean, what the minus would probably be, that would probably be the velocity if it was going back the other direction. In other words, that would be, you know, if it was starting here and going in this direction, then when it got to this point, it would be negative. We're going to now look at this problem here. This is 12-73. The water sprinkler positioned at the base of a hill releases water at 15 feet per second is shown. Determine the point B where the water strikes the ground on the hill. Assume that the hill is defined by the equation y equal 0.05 x squared feet. Neglect the size of the sprinkler. So we're going to take a look at this problem. And it's at the bottom of the hill. It releases a stream of water. And so it's going to, the water is going to start here. It's starting at 60 degrees from the horizontal. And the water is going at 15 feet per second. And now we're given an equation for the hill is 0.05 squared. And we want to know, like, say, if the water is being shot out here, where is it going to hit? What this point B? We want to know what is the point B, or what are the coordinates, maybe, huh? What are coordinates of B? So let's take a look at that. Just like before, usually the best thing is what, start out and find your velocities. Let's find our initial x velocity. That's just be what, 15 cos 60 degrees. Our initial y velocity, 15 sine 60 degrees. And that'll be 7.5. What do we work in feet per second? And 13 feet per second. So that just do, and almost all these problems, we have a projectile. That'll be your first step. Find those, just like we did in all these, find the initial velocity in the x and y direction. So now set up your equation just like we did before. Same, exactly the same thing. Do the x direction. X equals x naught plus v, whatever you want to call this, vx naught t 1/2 at squared. We've said a million times. Now we're going to assume that's 0. And now again, we'll figure it's starting right on the ground here. So let's figure the starting point is going to be 0, 0, huh? We'll just assume the starting point 0, 0. So when we put everything in, this is going to be 0 plus 7.5 t. I guess that's it, huh? So actually, this is just going to be x equals 7.5 t. Again, we'll call that our equation 1, because we're going to approach it similar to we did the last problem. We're going to end up substituting this into the y equation. So let's do the y equation now. Y naught plus vy naught t plus 1/2 at squared. And again, we're going to, our coordinates, we're starting at 0 plus 13t plus 1/2. We're working in English units, huh? So 32.2 t squared. And we multiply this out. Y equals 13t minus 16.1 t squared. And just like we did before, we want to substitute equation 1 into equation, oh, sorry, this will be equation 2. Let's substitute equation 1 into equation 2. And just like before, the way we have to do it, since this is in t's, solve equation 1 for t. So we want to sub equation 1 into equation 2. So we first have to solve equation 1. Equation 1 is t equals to, what's that going to be, x over 7.5. So solve that, and then put it into equation 2. Y is equal 13 x over 7.5 minus 16.1 x over 7.5 squared. And now if you square that 7.5 and divide it out on the second term and just divide it on the first term, if you put that in your calculator, this will all simplify to 1.733 x minus 0.286 x squared. So understand what this actually gives you. This gives you the position of the water at any point. In other words, this relates, let me say it this way, this equation relates the stream of water, the x coordinate to the y coordinate of the stream of water. So let's see. So how do we know? So we want to go find out where it hits the hill. And so it's, we want to know this point. Keep in mind what we're looking for. We're looking for this point here, right here, this point B where it hits the hill. And we know the equation for the hill is y equals 0.05 x squared. And again, this equation we have, this gives us the equation for this path. So we just found the equation for this path here. So how do we find out where it hits the hill? Exactly. Set the two equations equal to each other. Exactly right. Because they're going to intersect right here. It's just as though you're intersecting any two curves. Set them equal. Y is equal to this and y is equal to that. So let's set those two equal. So let me just say that set equations equal. Equal. And so when we do that, we get, let's put this, I'm not sure what the easiest way to do this. So let's go 0.05 x squared is equal 1.733 x minus 0.286 x squared. And so it's just going to be like it's sort of like a quadratic equation again, where we'll bring everything onto one side. Let's bring this x squared over to the left-hand side. And so that's going to be, let's see, yeah, when I did that, if I did this right, it looks like that comes out to be 0.336 x squared minus 1 point, and I'll bring the x, this other one over too. I brought everything over to the left. That's probably the easiest thing to do. Bring everything over to the left-hand side, get that. And so now I'll just solve for x. So we can factor out the x again, huh? And so once again, you see the solution is going to be x equals 0 or when this thing's 0. So set this one equal to 0. And when you do that, you end up setting that equal to 0. You end up getting x is equal to 5.16 feet. And then to find y, you can substitute back in either equation. Because it's intersecting at that point, so it'll be the same point for either. Well, I'll put it into the easiest one. I'll put it into the hill equation. So put this into 0.05 x squared. And so y is going to be equal to 0.05, 5.16x squared. And that'll be like 1.33 will be the y coordinate. So so the x coordinate 5.16, y coordinate 1.33. So that's where it's going to hit. It'll hit the hill, hits hill at 1.33.